Good afternoon, everyone. Today,
Good afternoon.
today we will continue solving problems from Newton's method. We continue the cosine example. You remember last time we started the cosine at the end. We started the cosine example, right? But we didn't have enough time to complete it. So let's do it again. But let me remind you, the Newton's method is this one. We have this formula: xn plus 1 equals xn minus fxn over f prime xn. Okay? But first you need to choose x1. You need to choose x1 close enough to r, the solution we want, and you also need to find the function if it's not given. So let's start here. Find correct to 6 decimal places the solution of the equation cosine x equals x. First method to find the value of x1 is to graph each function. See here. So you graph y equals cosine x, it's the red one. You graph y equals x, the blue one. Then here is the intersection. What would you like to choose x1? What do you think? Is one good? What do you think? Do you hear me?
Yes. One point.
One is good, right? Because it's very close to the solution. So we can choose x1 equals 1. Now if you want to choose x1 without graphing these functions, what can you do? We can use intermediate value theorem, right? I will show you now that you can also use intermediate value theorem to determine x1. So let's write the function first. We are given that cosine x equals x. Subtract cosine x from both sides, you get x minus cosine x equals 0. So call the function f of x equals x minus cosine x. If you want, you can call it cosine x minus x, as you like. It works both ways. But I prefer to start with x. Now we want to use the intermediate value theorem to see where is the solution, to choose x1 close to it. So let me remind you the intermediate value theorem. So let f be continuous on the closed interval ab, and f of a less than f of b, and you have n greater than f of a less than f of b. Then what's the result of this? Then there exists, let's write it in words. So there exists x1, there exists x1 belongs to open interval ab such that fx1 equals n. Good? Equals this n. So let's get back here. What's the value of n in our example? 0, right? For our function, we want n 0, right? Choose now a equals 0. What is the result? Because I want negative number here. Because what are the numbers less than 0? Negative numbers, right? Here I want positive result because I want something greater than 0, which is positive. Now choose f of 0. F of 0 equals what? 0 minus cosine 0. But what is 0 minus cosine 0? Minus 1, right? So this is good. The other one, for example, you can choose f pi over 2. F pi over 2 equals pi over 2 minus cosine pi over 2. What is cosine pi over 2? 0, right? So just pi over 2. So pi over 2 is positive, right? So there is r belongs to 0. Remember 0 here is a, pi over 2 is b. So from a to b is 0 to pi over 2. Such that f of r equals 0. Good. Pi over 2 is nearly 1.57. So you can choose x1 equals 1 if you want. You can choose number between 0 and pi over 2. 1 is good. 1 is good because if you calculate f of 1, you'll have 1 minus cosine 1. This is also positive. Okay? So 1 is better choice because 0 between 0 and 1 is better between 0 and 1.57, right? Because here we have more choices than here. So it's clear 0 between 0 and 1. The solution is between 0 and 1. So 1 is closer, right? So it's good to choose x1 equals 1. Do you have questions about this? Is it good?
Yes.
Okay, let's continue. So you need to understand this, that you can use intermediate value theorem to find x1. Now let's start solving. So we have f of x equals x minus cosine x. What's the derivative? F prime of x equals what? One minus sine x, right? Which is 1 plus sine x. What's the formula? xn plus 1 equals xn minus f of xn over f prime xn. This equals xn minus fxn, substitute xn in f of x. You get xn minus cosine xn over f prime xn, which is 1 plus sine xn. We want x1 equals 1. In this example, 1 is good. Now, let's find x2. Here we need it to be correct to 6 decimal places, okay? So again, we will explain this idea again because it's important. Let's find x2 now. What should we do first before using the calculator? What do you think?
What's the question?
Before using the calculator, I want to use the calculator, right? In this example, what should I do to make sure that everything is good? I need to make it in radians, right?
Yes.
So remember to set it for radians, okay? So let's start now. So the formula here, xn minus cosine xn over 1 plus cosine xn. So let's do it. It's radians and we can start. So you have 1 minus open parentheses, then 1 minus 1 cosine, close the parentheses, then divide, open parentheses, 1 plus 1 sine, close the parentheses. Now divide, you get this number. Let's see again our work to see whether it's correct. We have 1 minus 1 minus cosine radians 1 divided by 1 plus. Yes, it's good. Now the next step, here if you are using your calculator, when you want to find x3, you don't keep substituting x2 here, then x2 here, then x2 here. You click answer, okay? And on your calculator, you click this. So answer minus cosine answer 1 plus sine answer. Then x4, same idea. Answer. Is this clear? But me, I will use Control C and Control V. So let's do it. So now Control C, Control V, minus, open the parentheses, Control V, minus, Control V, cosine, close the parentheses, divide, then open parentheses, 1 plus, Control V, sine, close the parentheses, you get this number. Now let's see what are the correct digits until now. Here you have 1, here you have 0. So 1 is not correct, right? Here you have 7, here you have 7. So 7 is correct, right? You have 5 here, 3 here. So 5 is not correct. We have a 3 here. We don't know yet whether 3 is correct or not. I need to find x4 to know whether 3 is correct or not. If in x4 we have a 3, then this 3 is correct. Let's find x4 now. Do you have questions? So now Control C, then Control V, minus, open parentheses, Control V minus Control V cosine, close the parentheses, divide, open parentheses, 1 plus Control V sine, close the parentheses. So now you get 0.739085. Now, what are the correct digits until now? What do you think? What are the correct digits?
Seven, 3, and 9.
Yes. So since here we have 739 and here we have 739, we are sure that these are correct. This 0, we don't know yet. We need to find x5 to see whether 0 is correct or not. Let's find x5 now. So x5 equals Control C, Control V, minus, open parentheses, Control V, minus, Control V, cosine, close the parentheses, then divide, open the parentheses, 1 plus sine Control V, close the parentheses. You get this number. Do we have now 6 correct decimal places? We have it, right? We have 6 here, 6 here, and they are the same digits. So we know that these 6 digits are correct. Are you good with this? Do you have questions? Is it good? Okay. Show students the beauty of Doty number. The solution of this equation, cosine x equals x, is called Doty number, okay? I will show you something nice about Doty number. Remember the value. The value is this one, right? See the value again. 0.739085. Okay, remember this. Okay? Now let's talk a little bit about Doty number. So let's take the equation again. This equation here has the form f of x equals x, right? Good. But the function is cosine in our example. When you have this, this is called fixed point. Fixed point. Because you substitute something x, but the result is x. So it's fixed point, right? So the type of this fixed point is called globally. This is not included with you, but it's something very nice I want to show you. So globally fixed globally fixed attraction point. What's the meaning of this? The meaning of this that you can choose any number. For example, you choose, for example, what? For example, 3, for example. You keep applying cosine, cosine 3. Then cosine, cosine 3. Then again cosine, cosine 3. Again cosine. These values will approach the result of the solution. Okay? I will show you here. Let's do it. For example, start with the 3. Keep applying cosine. See? The value is getting close to the solution, right? So it's fixed attraction point. How to know it's globally? What's the meaning of globally here? It means that you can choose any number you want, and you keep applying cosine, you will get the solution. I tried the 3. Now tell me another number. What do you like? What do you want to try?
Professor, what did you ask?
I asked what? I mean choose number.
Any number?
Any number you want.
5.
Okay. C5 here. Apply cosine. Keep applying cosine. See, again it's going to the solution, right? If you want, you can choose another number. You can choose negative number if you want, as you like. For example, let's try square minus square root of 3. So 3 power 0.5 times minus 1, again minus 3 power 0.5. For example, you can start with this number if you want. You can start negative number and no need to be integer. Keep applying cosine. So you can choose any number and you keep applying cosine, you get the fixed point of cosine. So it has this property. But you can find the solution using Newton's method. This is what we need. We can find it using Newton's method. Now let's get back. What do you think? Is this property nice? Do you like this property? Do you even hear me?
Yes.
Is this property nice? What do you think?
Yes, it is.
Okay. Now let's see these exercises. So the figure shows the graph of a function f. Suppose that a Newton method is used to approximate the solution S of the equation f of x equals 0 with the initial approximation x1 equals 6. Here these two questions for understanding, because you need to use the formula xn plus 1 equals xn minus f of xn over f prime xn. But these are for understanding, okay? Because it's good to understand the method graphically also. So let's see here. The first part, we will choose initial condition x1 equals initial approximation x1 equals 6, okay? See here. So here x1 equals 6, right? Draw the tangent line, you get x2. x2 is nearly 7.6, right? Let's see here. 7.5. Last time I solved it, I put 7.5. Then 7.5, draw the tangent line. See here, the tangent line here. This one. You get x3 here. x3 is a little bit more than 7. It's what? 7.1. So this question is for choosing x1 equals 6, then x1 equals 8, to see which approximation is better. I mean, which using x1 equals 6 or x1 equals 8 is better to approximate the solution. Which approximation is better for the solution? Let's see here. x1 equals 8. If you start with 8, okay, you get the green tangent line, okay? Then you get x2 equals what? Nearly 7.3. 7.4, I put it last time. Then 7.4, draw now the red tangent line of 7.4. You get nearly 7, right? 7 is closer to S than 7.1, right? See here. S is a little bit less than 7, right? So 7 is closer than 7.1. So in this example, x1 equals 8 is better than x1 equals 6 to approximate the solution, right? Even though 8 is not close as 6 to the solution, because the solution is nearly 6.7 or 6.8, right? So 6 is closer. It's closer than 8, but still 8 is better for this example, okay? Now let's see the next example. You need to join earlier, okay? Now let's solve this one. Using Newton's method with the specified initial approximation x1 to find x3, the third approximation to the solution of the given equation. Give your answer to 4 decimal places. So this is f of x, and here you have x1. First you write the formula. What's the formula here? xn plus 1 equals xn minus fxn over f prime xn. What's the derivative of this function? Who wants to participate? F prime of x equals what?
6x squared minus 6x plus over x.
Thank you. Now let's substitute in the formula. You got xn minus 6xn squared minus 6xn over f prime of xn. And no, I substituted not correctly. Let's start with the f of x. Here f of x. So you got 2xn cubed minus 3xn squared plus 2 over the derivative now. You get 6xn squared minus 6xn. Good? Now we have x1. x1 is minus 1. Now here you need to be careful. When you substitute minus 1, you need to put parentheses, because minus 1 squared, for example, is it the same as minus 1 squared?
No.
So when needed, you need to put parentheses. For example, here we have xn squared, right? This one is the correct one. Minus 1 squared with parentheses. If without parentheses, you get minus 1. With parentheses, you get 1. Okay? Be careful about this. So let's start. We have x2 equals what? Where is it? Yes, it's here. So we have minus 1 minus, open parentheses, you have 2 times, then put parentheses for the minus 1. You get minus 1 cubed, then minus 3 times xn squared. So yes, so minus 3 times parentheses minus 1 squared, then plus 2, close the parentheses, then divide, open the parentheses, 6 times, open parentheses, minus 1, close the parentheses, squared, minus 6 times minus 1, right? So times I think we made a mistake here. Let me do it again. So we got minus 1 minus, open parentheses, 2 times, open parentheses, minus 1, close parentheses, cubed, then minus 3 times, open parentheses, minus 1 squared, plus 2, close the parentheses, then divide, open parentheses, 6 times, open parentheses, minus 1, close parentheses, squared, minus 6 times minus 1. So we need to put parentheses here. So again, minus 1 minus, open parentheses, 2 times minus 1 cubed, then minus 3 times, open parentheses, minus 1 squared, plus 2, close the parentheses, then divide, 6 times minus 1 squared minus 6 times open parenthesis, because be careful, if you don't open parenthesis it will be considered subtraction, okay? So open parenthesis minus 1 close two parentheses. Now you get this, you get minus 0.75. Now x3, the question tells you find up to x3. Now for x3 use control C and control V, okay? So control V minus open parenthesis, then 2 times open parenthesis control V close it, then power 3 minus 3 times open parenthesis control V close it, then squared, then plus 2 close the parenthesis, divide open parenthesis, then 6 times open parenthesis control V close the parenthesis squared, then plus, because it's negative number times negative number, then it will be plus 6 times 0.75. I made a mistake. Let's repeat it again. So control V minus 2 times control V cubed, then minus 3 times control V squared, then plus 2 close it, then divide, you get 6 times open parenthesis minus 0.75 squared, then plus 6 times 0.75, because it's minus times minus, it's positive. Close the parenthesis now. You get this number. Good? Yes, good. Do you have questions about this?
No.
Now let's solve this one. Do you know the lockdown browser?
Yeah.
So we will make a quiz very soon. When do you want the quiz?
Next week.
When?
Next week.
Next week.
Is Saturday good?
No.
Can you not do it during like now time?
No, it's not good during the lecture, because it will waste your time. Because in the lecture I need to solve a problem for you, so it's not fair to you to waste the time of the lecture with you solving the quiz. So it's better to. Can someone please make a WhatsApp group for us, okay? And send the link here, so we all join and we discuss it, okay?
Okay, I'll make one.
Now let's solve this example. It will be multiple choice quiz, and it will be very nice, and we will have two quizzes, one for mean value theorem and one for Newton's method. The total of the two quizzes will be 5, but so I will make one quiz 2.5 and the other 3 points, so you will have 0.5 0.5 bonus. Good, right? So I think a lot of you will get full mark because I will not make hard quiz. But you need to study, because if you don't study, even if I ask you what's the derivative of x, you will not know if you don't study. Okay? The derivative of x is 1, right? Easy, right? But if you don't study, you can't even answer this. So now let's solve this question now. Using Newton's method to approximate the given number correct to 8 decimal places. We don't have the function, right? Who wants to tell me what's the function? I think of making hard question for this idea. Hard question, but it's doable. You can do it. So, what do you think?
Professor, is the function x to the power of 1 over 4?
X power 4.
No, 1 over 4, 1 over 4.
X power 1 over 4. There is a better choice. Yes, you can do this one. Do you know, let me use your idea. I will use your idea. So you have f of x equals x power 1 over 4. Me, I would use like this. I will show you my idea, then I will use your idea this time, because it's better to try your idea. Because I solved using my idea before, so let's try yours. X equals 4th root of 75. So power for both sides, you get x to 4 equals 75. Subtract 75, you get x to 4 minus 75 equals 0. Then I want f of x equals x to 4 minus 75. This is my method, okay? But let's try yours now. What's the derivative of this? One over 4 x 1 over 4 minus 1. 1 over minus 1 is minus 3 over 4. Equals 1 over 4. I think I have a problem with this way. Do you know why? What do you think? Theoretically, this will work. But what do you think my problem with this method?
Will it take longer than the other one?
I don't know yet whether it will be longer or not, but the point is that I want to approximate 4th root of 75, right?
Yeah.
But here, if I am using this as a function, then I will be calculating things more complicated than 75 itself, right? For example, if I choose...
Doing directly 75 better?
Which one? So here, if you use this function, for example, if you choose x1, for example, equals what? Equals 3, for example. Then apply this, not 3, sorry, 81. You may choose it's 81 because it's close to what we want, right? So then you want to calculate in the formula. You want x2 minus f of x2. What is f of x2? 4th root of 81, right? Over then the derivative. You will also substitute in the derivative. But this, see, it involves what I mean similar problem to what we want to calculate. Say you find the result. Okay? Then next you want x2 minus 4th root of x2 over, you substitute in the derivative. So the problem with this function that you want to approximate 4th root of 75 by using the function itself. I mean the 4th root. So do you understand my point? Is it clear?
Yes.
So during the calculation of x2, x3, etc., we are using the first root of values, right? So if we can't find the first root of these values, then we can find 75 without Newton's method, right? So it's better to use easier function, which is my idea. I will show you my idea again. So let's delete this. But it's good that we discussed this. So if you use x to 1 over 4, I will consider it that it's not correct, okay? So we will use which function? Again, I will show you the idea again. X equals first root of 75. Power 4 both sides. X to 4 equals 75. Then x to 4 minus 75 equals 0. So this is our function, okay? So x to 4 minus 75. Good. What's the derivative here? 4x cubed. Then you have xn plus 1 equals xn minus f of xn over f prime of xn. You get xn minus xn power 4 minus 75 over 4xn cubed. Good? Good. Do you know, I want to make common denominator here to make it easier for me when I use the calculator. So it will be 4xn power 4 minus xn power 4 plus 75 over 4xn cubed. So I combined them, okay? What do you want x1 here? Please join the group so we discuss about the time of the quiz, okay? We will vote for the
Professor,
time.
I have an idea.
Ah, yes.
How about we don't do a quiz?
Thank you for your idea, but it's not good.
Why not?
Because we want the quizzes, so you cannot tell me that this is an idea. Now let's find the value of x1. So here, what's the value of f of 2? F of 2 equals 16, 2 power 4 is 16, minus 75, you get minus 59, right? This is less than less than 0, less than f of 3 equals 3 power 4 is 81, minus 75 equals 6, okay? Remember, I want the solution to be 0, right? X to 4 minus 75 equals 0, right? So 0 is between these. So my solution is between 2 and 3. Now, tell me which value you will take. x1 equals 2 or x1 equals 3. Which value is better? What do you think? What do you think? The solution is between 2 and 3. Me, I want to choose 2 or 3. Me, I want to choose 2 or 3. So what do you think?
x2.
No, think about it. Which value is better? I told you before that you need the
3.
value to be close.
3.
Why 3 is better?
Because it's close.
How is it closer? How do you know that? If over 3 is closer, why? The value is 6, right? Which value is closer to 0? We want 0, right? Which value is closer to 0? Minus 59 or 6? Which value is closer to 0?
6.
So, so x1 equals 3 is better, right? Good.
Yes.
So now let's solve. So I think for Newton's method, I cannot make it multiple choice because you may choose x1 different than me. So it's better to make it fill the blank. So for example, we make it x1 equals, you write the value you want, then x2. I think this, or better, I can tell you what to use. For example, I tell you use this, for example. No, it's good, no problem. Let's now find x2. So x2, remember here we want to approximate for 8 decimal places. We don't have more time, right? Okay, let's stop here. I will show you the solution. So you choose. The solution is not written here. So you choose.
Sir, we have quiz next week.
Join the WhatsApp group here. See the link. Okay. Join and we will discuss about the time, because I will choose time that is good for all of you. So we don't know yet the exact time because we need to discuss it first. Assignment and the quiz are nearly the same thing, so don't worry about it. The difference is just the quiz you will solve it. You will solve the quiz at fixed time. Yes, this is the only difference. So we can agree on the time.
Professor, I just wanted to mention that some of us that are programming, we have a midterm on Saturday, so we just need to discuss about the time.
Yes. It's not necessarily Saturday. You can choose another time. We will discuss it here. Did you all write your names and student ID? Yes. I will take the names and you can leave if you want. Have a nice day.
Thank you, Professor.
You're welcome.